Okay, so guys, in this video, we have to solve this question in which it says that you have to find the derivative of this function root x plus 2. And if you are confused about derivatives or differentiation using the first principle method or differentiation using the ab-initio method, so you can watch my video which has just appeared on the topmost section of the video. It is displayed as a card, and it is an introductory video related to the differentiation and differentiation using the first principle method, or which is also known as the ab-initio method, or the method to solve differentiation or to find the derivative of a function using the definition method. So I'm going to be really quick in this video because we have mastered all those skills in which we can perfectly find the derivative of any function. So let's just begin, and the steps are shown on the right hand side of the video. So let's just do our increment, and I would also increase my the dependent variable x plus delta x plus 2. Now I've just moved the y to the right hand side of the equation, okay, and it becomes a negative, the signs will change, and now I'm going to put the value of y, that is x plus 2. Okay, so if you just look at it, let me just write it in this form: 1 by 2. It's a root and a square root actually, so it is 1 by 2. What can you do? You can see that there is a power, and wherever there is a power, you can use the binomial series method to find the derivative of any function, and that's the most pretty and the most useful and the most easiest method to solve for the derivative of any function. But that is applicable only for the questions in which you have to find the derivative using the first principle method. Okay, so now you can see that there is an x plus 2 over here, so I can take out x plus 2, 1 by 2 common, and what is remaining over here, this is x plus 2, so 1 plus delta x divided by x plus 2, and there's a power over here, 1 by 2 minus 1. Okay, this 1 is just because these two are common, so we are taking out 1 common over there, so x plus 2, 1 by 2. Now we are going to expand this whole thing via the process of binomial expression method. Okay, so 1 plus the power delta x divided by x plus 2. Now again 1 divided by 2, and we are subtracting it by 2 factorial. So I can simply cancel 1. Sorry, I forgot to tell you about that from where this negative 1 came. This negative 1 is the same which we had common in the I guess 5th or 6th step. Yep. Now we can move on with the further simplification, and you can see that there is delta x, and there is also a delta x over here which is common, so I can take out delta x common. So what would happen? We are left with 1 by 2 x plus 2, 1 by 2 x plus 2. Okay, now this term is actually 1 by 2, and interesting part is that I'm not going to simplify this term because it would be cancelled at the end of this question. You will find out how this will be cancelled. Now you can see that there's delta x squared divided by x plus 2 squared. Now we have taken out delta x power 1 common, so what remains is delta x divided by x plus 2 whole square. There's a square over here, there's a square on both of these terms. Okay, so plus. Okay, one last step is remaining, and that is dividing delta x. We are actually moving toward the ending of this question, so I'm going to divide delta x on both sides, and now we are going to apply the limit. So you can see that we can easily apply the limit now, and we are good to go. Delta x is equal to limit. I am just going to put the limit on the top, so this just because there is no more space left for writing anything. So x plus 2, 1 by 2 remains. Wherever there is a delta x in the equation, you can simply put a 0 over there. So there is delta x over here, so this becomes 0. This whole term becomes 0 because it is being multiplied. That's why I was telling you in those steps that you do not need to simplify this term because this is going to be cancelled. So this remains. And what is the answer? Yep, x plus 2, 1 by 2, 2 x plus 2. Okay, so this is the required derivative of the function root x plus 2.